Hello all. So in this lecture we are going to learn the economics of power plants. In last lecture we have seen that what is the meaning of economics of power generation, what are the various factors included while calculating the various parameters related to power generation. Now we are going to learn the economics of power plants. Basically, whenever we are going to design a particular power plant, there are some factors which are to be taken into consideration. In last lecture we have seen that how a economical load curve is drawn for a particular residential or commercial system. Then based on that load curve, we have also seen that how a load duration curve is drawn. That was the difference between the base load, intermediate load and peak load. So for the generation of power, we were requiring various parameters or values of average load, that is the average demand, then maximum demand, then the number of working hours of that particular plant, etc. So these are all the concepts related to power generation. Now we are seeing the various economics of power plants. So the factors affecting power plant design. So we will start with the first factor, that is the location of power plant. So while designing a particular power plant, the intuitional requirement is that the location of the power plant should be taken into consideration. The second factor which is affecting the design is availability of water in power plant. That is how much quantity of water is available, because water is the source of energy. At the same time, the water is required for several industrial processes. So therefore, availability of water in power plant is a one factor to be considered. Then availability of labor nearer to power plant. We know that any work cannot be completed without human being. So basically, for designing a particular power plant or for working in actual power plant, some labors will be required. So that manpower which is required, that should be the availability of manpower at that particular time, at that particular cost, also is considering a factor. Then land cost of power plant, the cost of the land also is affecting the power plant design. Then the factors again to be considered are low operating cost, then low maintenance cost, low cost of energy generation, and low capital cost. So now we are going to see in next slides that what are the effects of power plant type on costs. So see, the cost of a power plant depends upon when a new power plant is to be set up, or an existing plant is to be replaced, or plant to be extended. So see that how the categorization of the power plant type on cost is, first we have to determine whether a new power plant is to be set up, or we have to make some modifications in the existing plant only. We have to replace some machines, we have to replace some extra accessories of that particular plant, or this plant is to be extended. So the plant to be extended means, suppose a power plant was giving us a output power of around 10 megawatt, then we can say that if we have to extend, that is we have to increase the power output of that particular plant from 10 to 50 megawatt, so that is known as a plant to be extended. So this cost analysis includes two types of costs, that is fixed cost and operational cost. So what does fixed cost include? It includes the initial cost of the plant, then rate of interest, then depreciation cost, then taxes and insurance. And operational cost includes fuel cost, then operating labor cost, maintenance cost, then supplies, then supervision and operating taxes. So the cost which is going to be implemented during the design of the power plant is divided into two costs, that is fixed and operational cost, and these costs are having sub under categories, and therefore these categories are there explained in the further slides. So we will start with initial cost. The initial cost of a power stations include the following. So see how the initial cost is divided. First it is land cost, then after land cost is there, then building cost, then after building has been constructed, then equipment cost, and then installation cost. And over all this you are having overhead charges, which will include the cost of transportation, stores and storekeeping charges, then interest during construction, and etc. So basically this initial cost will include the cost related to the buildings, cost related to equipments, cost related to land, etc. Because this initial cost can be regarded as the fixed cost, because basically in all the concepts or all the systems which we are going to employ in power plant, these initial costs will be a one time investment costs. Because when we are going to take example of a land cost, we can say that if we purchase a land, it becomes a permanent asset, and therefore this permanent asset will suppose to be a very fixed cost, and so it is known as a one time investment cost. So similarly, based on this type of initial cost, the various costs are dependent. So we are going to see now next, rate of interest. After seeing initial cost, rate of interest, all enterprises need investment of money, and this money may be obtained as loan through bonds and shares or from owners of personal funds. Now see that when we are going to implement a power plant design, the initial cost is much higher, as we have explained in last slide, that the cost of the plant is one time investment, but it is a huge amount. So basically, and this amount or this money to be generated can be taken in terms of a loan through various systems. So therefore this rate of interest is dependent upon the amount of loan and the period of the loan. So see, interest is the difference between money borrowed and money returned. It may be charged at a simple rate expressed as percentage per annum, or may be compounded, in which case the interest is reinvested and adds to the principal, thereby earning more interest in subsequent years. So they see that whenever a money is purchased from or money is borrowed from a personal institution or a industry person or a personal funds or shares, etc., then this money is given at a certain percentage annum rate, that is known as a rate of interest. So it determines that the money which will be returned will be dependent on the rate of interest for a particular period. And even if the owner invests in his own capital, the charge of interest is necessary to cover the income that he would be derived from it through an alternative investment. So see that nowadays the investors are investing in their own plant for delivering the various amount of taxes, and so this gives a one rise to that particular concept of a bank, that amortization is the periodic repayment of the principal as a uniform annual expenses. So basically while when a power plant is to be designed, the initial investment will be taken up from 4 to 5 borrowers, and then after some payback period, the amount will be refunded to the investors, and therefore it is known as a share. Then depreciation. Depreciation accounts for the deterioration of the equipment and decrease in its value due to corrosion, weathering, and wear and tear with use. Now see that this depreciation is actually related to the equipment, the use of the equipment. So whenever a new equipment is purchased, actually this equipment is related with their depreciation cost. So the depreciation cost is dependent based on the amount of corrosion the equipment has taken up or amount of the wear and tear in its use. So it also covers the decrease in value of equipment due to obsolescence. With rapid improvements in design and construction of plants, obsolescence factor is of enormous importance. So availability of better models with lesser overall cost of generation makes it imperative to replace the old equipment earlier than its useful life is spent. So see, in this point we have mentioned that the availability of the better models with overall, this is less overall cost of generation, means what, when a old machine is to be replaced by a new machine, then this depreciation cost is very useful, because it adds the amount of the funds which we are going to invest in the new models. So the actual lifespan of the plant has therefore to be taken as shorter than what would be normally expected out of it. So this is the major point here, because if we are designing the plant for operation of 50 years, then we will say that the depreciation cost will be calculated for only 40 years. Then the following methods are used to calculate the depreciation cost. Now there are four methods which are used to calculate the depreciation cost. That is straight line method, then percentage method, then sinking fund method, and unit method. So we will see the first method, straight line method. It is the simplest and commonly used method. So see actual what is included in this method. Now the life of the equipment or the enterprise is first assessed as also the residual or salvage value of the same after the estimated lifespan. So the in this method, first thing is done is the life is been assessed. That is the life of any equipment or life of the power plant is first assessed, but at the same time it is compared with the actual value or the residual value when estimated lifespan is there. Means what, when the machine is purchased or when a power plant is designed, as we have seen that if power plant is designed for 50 years, but still the actual life is expected up to 40 years only, then this salvage value is deducted from the initial capital cost and the balance is divided by the life as assessed in years. So this value which we received from the upper area will be deducted from initial capital cost, because when we are investing the cost, we are investing money in the initial capital cost of the system. So as we have explained that this method is related with only equipment or the enterprise means the power plant, and the remaining balance is divided by the life as assessed in years. Thus the annual value of decrease in cost of equipment is found and is set aside as depreciation annually from the income. So when the difference we get, that is the initial capital cost and the life assessed, this separate value is kept as a aside as a depreciation. Therefore the rate of depreciation is uniform throughout the life of equipment. By the time the equipment has lived out its useful life, an equivalent, that is amount equivalent to its net cost, is accumulated, which can be utilized for the replacement of the plant. Then second is a percentage method. In this method, the deterioration in value of equipment from year to year is taken into account and the amount of depreciation is calculated upon actual residual value for each year. Therefore it reduces for successive years. So in this percentage method, the year by year account of the life of the equipment is kept, and therefore in every year this depreciation cost is reduced. What happens is when the equipment is new, so after 1 year of operation it has highest depreciation value, then after 2 years of operation this depreciation cost reduces. So up to, suppose its lifespan is 20 years, so up to 18 to 19 years its depreciation cost is continuously reducing. So this is the way in which some depreciation is calculated with percentage method. Then sinking fund method. This method is based on the conception that annual uniform deduction from income for depreciation will accumulate to the capital value of plant at the end of life of the or equipment, of the plant life or equipment. In this method, the amount set aside per year consists of annual installments and the interest earned on all the installments. So in this sinking fund method, one area which is developed is that the depreciation cost which is kept aside can be used as an investment for the installment of the new machine. So when we are simultaneously using the new machine, and when we are going to calculate the depreciation cost, at the same time the amount which is kept aside for the depreciation is used as an investment for the another new machine after 20 years, so that when the 20 years of the particular machine will be completed, then we will have a sufficient amount of funds which can be used to utilize the purchase of the new machine. Then unit method. In this method, some factor is taken as a standard one and depreciation is measured by that standard. In place of years, equipment will last the number of hours that equipment will last is calculated. This total number of hours is then divided by capital value of equipment. This constant is then multiplied by number of actual working hours each year to get the value of depreciation for that year. In place of number of hours, the number of units of production is taken as the measuring standard. Now see, in this unit method, there are two factors considered. If the consideration is done for the equipment in place of the years, how much years it will last, then the how much number of hours it has been in use. Suppose there are 8 hours in a particular day the equipment is used, so this total number of hours are calculated, that is suppose for year. So if every day 8 hours machine is running, so 8 multiplied by 365, and this total multiplication will be divided by the capital value of the equipment, and therefore this we get is a certain value of a constant. This constant is then multiplied by the number of actual working hours each year to get the value of depreciation. So when we multiply this to the actual working hours, again we will get the value of depreciation, and therefore this is taken as a measuring standard. Now next we are going to see the operational costs. These elements, the elements that make up the operating expenditure are follows. Now for running the operational cost, when the initial investment has been done in land, building, then construction, then installation, etc. Now we have to see that how the equipments are to be utilized. So for utilization of the equipments, these operational costs are taken into consideration. So the first is cost of fuels, then second is labor cost, then third is cost of maintenance and repairs, cost of stores, that is other than fuel, supervision and taxes. So the first is cost of fuels. Now see that now before going to the slide, we will explain the general concept of cost of fuels is whenever we have to run any particular power plant, we have to give the initial charge to the particular power plant. So this initial charge will be helpful when we implement the fuel in the particular power plant. So therefore for designing any power plant, the cost of fuel is more important. In a thermal station, fuel is the heaviest item of operating cost. The selection of fuel and maximum economy in its use are therefore very important in considerations in the thermal power plant design. It is desirable to achieve the highest thermal efficiency for the plant so that fuel charges are reduced. So see that for achieving the highest thermal efficiency, we are considering that the fuel charges are to be reduced. The cost of fuel includes not only its price at the site, but the price of its purchase, and at the same time it's the price of the transportation of fuel, and also the cost of handling of the fuel. Plant heat rate can be improved by the use of better quality of fuel or by employing better thermodynamic conditions in the plant design. So see that the cost of the fuel is related with these quantities. So the cost of fuel varies with the following, that is unit price of fuel, then amount of energy produced, and the efficiency of plant. Then second is the labor cost, which is nowadays a headache for all the industrial persons, that the labor cost is increasing, at the same time the productivity is reduced. For plant operation, labor cost is another item of operating cost. Maximum labor is needed in a thermal power plant using coal as a fuel. A hydraulic power plant or a diesel power plant of equal capacity requires a less number of persons, because see that when coal is used, it requires a maximum amount of labor, because the handling of the coal is to be done, the transfer of the coal is to be done from one point to another. And what happens in hydroelectric or a diesel power plant, once the system is started, then only the cost of the labor is related with only maintenance cost, and therefore at the same capacity as compared to thermal and diesel or hydroelectric power plants, the hydroelectric or diesel power plants require less number of labors. In case of automatic power station, the cost of labor is reduced to a great extent. However, labor cost cannot be completely eliminated even with fully automatic station, as they will still require some manpower for periodic inspection. So see that there are certain automatic power stations available. Then in industries also there are certain automated industries, but we cannot directly fully eliminate the labor cost, because there are certain areas where the manpower is a must for analyzing the systems or for periodic inspections, for maintenance purpose, etc. So the labor cost cannot be completely eliminated. So we have taken the effect of power plant type on costs as the second part after the cost of fuels as labor cost. Then third is cost of maintenance and repairs. So in order to avoid plant breakdowns, maintenance is necessary. Maintenance includes periodic cleaning, then greasing adjustments, then overhauling of equipments. The material used for maintenance is also charged under this head. So see, while power plant design is to be done, the several costs we are taking into consideration. This is the continuous cost, and this is the unbearable cost for any power plant design: cost of maintenance and repairs. So there certain after certain hours of operations, there are certain ways in which lubrication is required for any machine, or cleaning of the particular machine is to be done, or for example in order to reduce the heat rate, lubrication is to be provided. So there the maintenance and repairs are required. After certain breakdowns also, this also comes under maintenance, that if a machine is completely breakdown, then the maintenance is to be done. So therefore this cost is also required. So while doing this maintenance, certain materials are required to be borrowed from outside the power plant. So therefore this also comes under the maintenance cost. A good plan of maintenance would keep the sets in dependable condition and avoid the necessity of too many standby plants. And therefore the repairs are necessitated when the plant breakdowns or stops due to fault developing in the mechanism. So see that suppose there is a breakdown of a power plant or machine, or we can say that if the certain orders of the electrical power are less. So if the power plant is off at some time, or power plant is off due to certain another mechanism failure, then at that particular time only the maintenance should be done or the repair should be done. So this will require a certain plan. The maintenance sheet is to be provided, and in that maintenance sheet all the plans should be done in order to actually maintain the particular machines. And the repairs may be minor, major, or periodic overhauls and are charged to the depreciation fund of the equipment. This item of cost is higher for thermal plants than for hydro plants due to complex nature of principal equipment and auxiliaries in the former. Then cost of stores. Now, whenever we are requiring a particular power plant design, when we are doing power plant design, the requirements of consumable materials are there. The items of consumable stores other than fuel include such articles like lubricating oil, greases, then cotton wastes, small tools, then chemicals, then paints, such other things. The incidence of this cost is also higher in thermal stations than in hydroelectric power stations. So this is nothing but the cost of the certain extra materials which are required to process during the power plant operation. So therefore this cost is also taken into consideration. Then another cost is of supervision. In this head, the salary of the supervising staff is included. This also determines that the cost of the labors, then the cost of the supervision. The good supervision is reflected in lesser breakdowns and extended plant life. The supervising staff includes the station superintendent, chief engineer, then chemist, then engineer, supervisor, store in charges, purchase officer, etc. So see that this cost of the supervision is also more important, because when we are going to employ the cost of when we have to design the power plant, we have to take into consideration this costs also, because as we have explained in last slides that there will be no plant that which will have a no labor. So when labors are considered, the inspections are done, and therefore the inspection cost is also been provided. So the supervision cost comes into existence when these type of staffs are included for smooth operation of the power plant. Again, power stations which have coal feed have greater incidence of this cost than hydroelectric power stations. And then the last cost is the taxes. Now, when the power plant is run, there are several taxes levied by the government on this. So the taxes under operating head includes the following: income tax, then sales tax, then social security and employees security, etc. So these type of taxes are basically the amount given to the government on the basis of the last year of operation of the power plants. So see that these all costs which we have seen, these all are considered as a whole and they are considered in operational cost. So these operational cost and initial cost are added, and these are giving us the total cost of the power plant. So basically, while designing any power plant, we have to take into consideration these costs, and then we have to apply certain conditions, and then the final output of the power plant will be calculated. And the main thing which is there here is, while we are supplying, or when we are finding out any cost of a particular power plant, the cost of power plant is related under these categories. And when these categories are the major advantage of doing a power plant design is to reduce these type of costs. As we have seen that we cannot eliminate all these types of costs, but we can surely reduce these type of costs. So therefore, the effect of the power plant types on costs is a very important aspect while we are designing any